Hello again. In previous episode we have created this basic element, and now we would like to use it. So we would like to transform this model, instantiate it from this basic element into new one, and there we will make a patterns which we will apply on the release geometry. So first, for this we will need a new part, so Ctrl N, supposed to do it. It will give us menu where we will choose the part. This part will rename as a stitch template or sim template, so reference sim template, and we will save it. So now we have it saved. We can see it as well additional properties on the top if such were defined in the preferences. And now let's rename this geometrical set. So feature properties, feature name, references. Then we can isolate directly this axis system, as we want to have again full control over it, and we will move this axis system with us in the instantiated parts. And now we can start creating some geometry on which stitch will be applied. So for that we will need additional set. As tree is very short, we can use those supporting icons on when you selected the body or the container, pardon, only on body, and we'll rename this in inputs. As an input, we need exactly that what we want to use later as input, and in this case this will be one curve and one surface. Simplest way to create it for me is with image and shape, but feel free to create curve and surface as ever you prefer, because there is no difference between these. So we just need one face in some orientation. We don't even care about which one. I'll just make it slightly more complicated so that we have a couple of faces in this geometry, so that we can later see that the stability will be guaranteed even though we have multiple patches. So this was one, now we can add one more. This one we will just extend a bit. So let's extend it a bit, let's cut it once again as well, just to have slightly different geometry, and now we can go back to generative shape design. So let's switch, generative shape design, let's do intersection between these two surfaces, and we'll have shape like this. So this curve we will use as an input, and based on this curve we will apply those stitches that we created before. Here we can eventually check the length of this curve, so that it's not eventually way too long. In this case we have 100 millimeter, that means 20 elements, which could cause us performance issues, which we don't want to have. So shortly back to image and shape. I just scale everything slightly on the half, so 50 millimeter will be enough. Squeeze it in both directions, because we just need a simple reference on which everything will be applied. So we have enough input here, and now we will start applying geometry in this. So let's go back to generative shape design, and we can additionally create one helping element. I usually prefer to know orientation of such elements, even though it's not necessarily the oriented. In this case we will add one small circle on one of the edges of this element with size of 1 millimeter, so we can even zoom it in, and we will change it to full elements, and we can even change the color of that element so that we know what it is. Why we are creating this element as well. Let's change this color, so less aggressive color. So why did we change this color? Why did we create this element at all? In this way we can orient our surface, so we have center line and we know what is left and what is right, because we will need the left and the right line as supports, and we will have to organize these three as well according to this. So we have now our beginning, our orientation, and now let's bring in the reference element. Reference element is supposed to be a bit inside of this reference, so like deactivate it. And in order to do that, we will, in this case, simply select the template that we created previously, and from tools instantiate this power copy, this user feature, instantiate from selection. And as we don't have any inputs for this, we'll just confirm it. So this was super simple template, which is just bringing in this geometry that we had. As you can see, orientations are different, and we will have to control these orientations later, but how this is going to be done, we will see soon. As well, we might even grab these elements and reorient it so that they approximately look like the reference, but we can do that later as well, so that we see that the updating is relatively stable. So we got our stitch. We can still modify all these parameters, so we can say length is not 4.5, length is 5.5, and if we confirm this and update it, it's supposed to extend it, so we can as well put it back on 4.5, update, and the same way we can modify all other parameters. So as a sim itself, as this user feature itself, the first element will be our sim. Second element is the face on which is line, and then we have those two curves. They are left and right. Technically we can even rename those so that we know later easier what they are. So face, curve left, curve right. So we have our elements. Now we will need additional set of parameters, as those are not enough anymore. We need parameters for the length, we need parameters for amount of elements, and for additional tuning, and all this we will add now. So let's add first parameters, formula. Again, they will be moved to references, as by default they will be created outside. So parameter type length. First parameter will be width of this area that we are using, so line width, and we will define it as formula. Add formula, add formula. So we will calculate it from the height of the stitch itself, and we will just multiply by 3.5, so that we know that it's slightly bigger than this stitch itself. So this will be width here, but we will come later to that. Then we will need new parameter of type, same type, so we will call it curve length, curve through length. How long this curve is, we will measure exactly projection of this input, but as we didn't create yet projection, we will just leave it open. Then we will add the number of elements, seams, which as well will be calculated as length divided by this stitch length, 4.5 millimeter, and we will make an integer out of it, so we could even define it directly as an integer. Yes, we can do that. So this parameter itself we can delete parameter, yes, and we can make an integer parameter of seams. As said, we don't know how many we have. Then next parameter is again length. We will call it mapping length. And this parameter will be again calculated as number of stitches multiplied by the length. And we can do one more parameter again as an integer. So we will call this parameter extra elements, extra seams, which will give us possibility to add extra element, to squeeze it a bit more if necessary. This is quite useful when the integer is not really rounded up how we want it, because the integer will be rounded up on 0.5 millimeter, and sometimes 0.5 millimeter bigger element is looking less appealing than the two smaller elements that are sharing this 0.5 millimeter. So if we confirm this, we'll see again these parameters created there where we don't want to have them. In this case, we can just grab everything and just put it inside. Important is that we have our parameters inside. We can even rename these parameters into seam parameters, and later we will rely everything on those parameters. Now we will select our references and put them into subset as a subset into container. So let's just select the set and call it CM line. So this will be our master set in which all the inputs, all the geometry that is going to be instantiated later is going to reside and proceed. And now we will add additional set here. So set basic curves. In these basic curves, we will grab our reference curve, which technically can come as an input, as a bad input where that curve doesn't really lie on the surface. So we'll grab that curve and simply project it. So let's do projection, wireframe projection, project this curve on the surface, and we can additionally project it, of course, on the normal, and we will additionally do some smoothing on it with a simple parameter. Reason for that is that curve can have some breaks, and we want to slightly modify those if possible. So we want to have like nice clean input. Now we don't need this intersect anymore. Hide show. Of course, in this case, these two curves will look very similar. Only difference is, you can see it already, is that this one has extra points that we have now less. And this can help us later, as we'll do a lot of parallel curves and operations with those elements, so that we want to keep things as simple as possible. And this gives us now possibility to map this parameter, to define this length. So curve length, we can now do the measurement and apply it through the formula. To do that, we will open curve through length. We will say edit formula, and we can use these part measures, can't we? And part measures, we can use the measures, and we can select the length of the curve. And curve, it's in this case this projection, so we'll select it. Why we did it in this way? Because here we can keep the updating of the element according to change in input. We could theoretically do the measure, but measure is not so stable, and I would rather always recommend to use the formula with length instead of measure. Then, as we have now the curve length, now we can adjust the number of seams. So again, formula, everything will be formula. So formula is very simple. It's this number of elements divided by 1 millimeter. Why that? Because we first have to get rid of the units, and they will as well divide by length of the stitch. as the stitch as well length is in millimeters, we don't need to do that. So we'll just divide it here and we'll get our 10 elements. And now we have as well extra parameter for mapping length. Mapping length we will define as number of seams multiplied by length, and let's do that as well. So we know always that we will use this difference between these two elements and this tolerance that we will have, but because of this we can always control that the beginning and end are always ending on really on beginning and end. So multiply number of elements by millimeters, and now we have 45 millimeters. So from this 45 millimeters we will calculate the length, we will do the parameters, we will do patterns, we will create all the geometry. Let's continue creating geometry. So all these sets we can keep it even open, but we'll need here additional set, which we can call preparation. In this preparation set we'll have a couple of other sets like the supporting surface for the stitches, then we will have the shape of a pattern of the stitches, flat pattern, and of course we will have blackouts. But in preparation first we need this base surface, so base, new set base face. So what is this base face? We will calculate it from this element here, or create it similar to this element here. First we need one line of this from origin. In fact we can even do it properly with nice point in 0, 0, 0. Now we'll create a line which is slightly longer than this width from this point and this direction, symmetrical, and we will attach it to this form of parameters. So let's grab it. Of course it has to be double width of this line in total, so we will take a half on both sides, 1.4 millimeter on both sides. Unfortunately we can see here the one small mistake, that this parameter is not optimal. Let's adjust it. It's not big enough. Let's multiply by 4. Okay, update. So we have slightly bigger element. Now we will extrude it and cut it with these curves. So let's first extrude it. Surface, extrude, element in X, and edit formula minus stitch length. We got stitch length, so it will cover exactly the same size of element. And then we can do a couple of splits, split, where was split, transform, split. So we'll select the element, we'll select the splitting element, so one side, and of course in this case we'll use element to remove is this point, so this side will disappear, we will keep on the outer side, and again we will need same on other side. So we'll unhide this surface, split again, so we can split even from here, from 3, we will split it with that curve right, and of course we will element to remove again this point. In this way we are 100% sure always that exactly this outer shape will stay. Now we will simply join it, and now we have a regular element that we can apply on the flat plane. So this curve left right we don't need anymore, parameters we'll need, so keep them open. So we modified our input already, and now we can start making patterns. First we will prepare a set in which line will be stored. So in preparation set we will add additional geometrical set that we'll call the line. In this set first we will create a top surface that we will use later as a reference. So wireframe line from this point in X direction in opposite X direction. No, it's correct X direction, just without this other side. And here we will add formula. Length will be total length, and total length is this mapping length. So we'll have a line of, in this case, of 45 millimeter, where we'll make a width of this area exactly as wide as this seam here, this object, this component. So let's do this extrusion. We'll select this line in X direction, and the parameter will be edit formula line width, of course on both sides. So this will give us support for later. This is stored here in set, and additionally we will need outer two curves, so we can do as well those transformations with translate in direction of y. Distance is of course formula, one's positive, one's negative. So we'll just simply copy paste it, and in formula we'll add minus. In this way we created outer two curves, and now we can add another geometrical set where we will hold seam information, or just call it pattern. So this line we will hide for now, and let's do pattern. So we'll do regular pattern, very simple one, from this object from seam base. As you're getting this error here, capability is not available. It's simply because Catia doesn't allow the elements from different set to be used as a reference for the patterns. So we'll mask this, we'll take our seam, translate it in some direction with parameter 0. In that case we created a new element which is exactly in this set, and now you can see the Catia will allow us to make this pattern, which is completely ridiculous. But we want instance and spacing. Instances in this case is formula number of seams. Spacing as well we know, edit formula is exactly stitch length. Position is there, that's fine. We just need the reference element, and reference element is x-axis. So in this case we will get this amount of elements. I just forgot that actually we need one more element, plus 1. Why we need one more? Because we have this element of minus 1, and we actually want really 10 elements. So 2, 4, 6, 8, 10. And now we can confirm this. So seam is here, we don't need even to join it anymore, because this is one group. We can prove that here. Then we need same for the supporting surface. In order to do that, we'll simply copy paste it, copy paste. We'll copy paste it in the same set, and we will simply replace the input in surface. So in this case we are getting the line of the elements and their supports. As these supports are currently not a unique element, they are not joined, we will join them, and we will simplify result. I can even show you what happens with and without. So there's supposed not to be a gap. That's funny. Of course we have a error, because in the second pattern we added two elements, which was not really desired, so we don't need this translation. Then remove X, confirm. So now we have only the surfaces, and now it's supposed to give us possibility to do this join with event 001. So why we want to use simplification there? If we check in view shading with edges, we'll see that there is additional split between all these faces, and we want to have minimal amount of elements, because this gives us better possibilities by tessellating of this geometry later for visualization purposes. So let's use this simplification, and now you can see now we have one single face here for the whole length. So if we have 10 or 100 elements, there will be still only one single element. So now we don't even need these references anymore that we had here, this stitch, and as well sim base we will not need, and this sim supporting face which we joined, so we don't need all of this. We will need only not base, we'll need the line, as we will transform those. Before we continue on the next step, we will simply add one parameter that we are missing in this number of instances, and the part of this formula is missing actually extra sims, so let's add them as well, as we want to have possibility to add extra elements. Then as we modified it here, we will have to modify it another one, pattern. So here we will add the same, this will give us possibility to modify the length in the way that we can change the number of elements here in extra. We can have two elements extra, and if we update it, we'll see that these elements will be added. Only issue is that this is not following, so we have to adjust this as well. Here as well, formula will have additionally added extra sims multiplied by length. So in this case we're supposed to get same correlating surfaces. And now we can go to next step. Then now we will add blackout. In order to do that, we will simply hide this upper one so that we see what we are doing. And in order to do it, blackout will be a simple surface beneath the seam that is covering this hole so that we don't see through the material. In order to do that, we will create one point from 0, 0, from this origin. So from origin, from references point 9, which was created in origin, we can go simply in formula, edit formula. We know that depth is 0.6, as we adjusted this in other files, so it was 50% more, 50% more than height. So let's do it once again. 1.5 minus. In this case, we don't need X, we need Z. X, okay. Formula, same value. Now we can add one line which is slightly bigger, slightly wider than this cutout. So let's do that. Point we selected, in direction is Y. Length is edit formula. is width of the stitch, multiply by scale, multiply by 1.2, 0.2. In that case, we have an element which is slightly wider. We'll as well use the symmetry. And now we can extrude it in the same way as we extruded the upper surface. In order to do that, we'll simply use extrude, select this point, select this line, direction, and length. We will again avoid calculating anything. We'll simply edit formula, and we will find this line that we used before and reuse the parameter. In this case, now you will see that we have same length on both elements. Later there is a possibility to add additional extensions in order to mask the gapping on the element, but we can leave that for another time. Of course, this blackout that we just created, we can put it in on set. So let's select the geometrical set, that's black out, and let's move it in the same order, same level. So in preparation set. Now it's time to finally start using our inputting geometry, and we will do it by adding additional geometrical sets in our basic curves, where we'll create a left and right curve which are corresponding to outer curves of this pattern. So let's add geometrical set in this basic curves. No, let's call it left. Why left? Because we'll make parallel curve on the left side and then do tuning first on the left, and then afterwards we'll do the same on the right. In wireframe, we'll take parallel curve, make parallel curve on this support as we projected this curve before, and we projected it exactly so that we can do this parallel curve. Distance in this case is line width. Positive one is left in this case. Then additionally we'll do some smoothing. We can use curvature with a bit of deviation. Why we want to use this deviation? Reason is simply to compensate a bad input, which can result from importing geometry from different systems, where the tolerances are set up differently and join or healing is holding geometry together. In this case we'll get a surface, pardon, we did it wrong, this is the right one, as the left one, we said we will start everything from this ball. So in order to make this left, let's grab this parallel and simply add minus in front. So now we have it as a left one. Then we can see here as well that beginning is not really lying on the beginning of that surface, and we want that definitely, because otherwise with more angle we will have more deviation from it and stitch itself will start creating gaps, and that's something that we want to avoid, and we can avoid this. In order to do this, we'll have a couple of additional parameters. So we will have overrun set of parameters, which will be as well length, overrun left begin. Some default value is set to 4 mm because this has shown as a very good value to cover all the possible gaps without coming into problems when having curves with a very small curvature at the end. Additionally, of course, we want to have it on the right, on the end, overrun left end, same for millimeter. Then we want same for the right side. Begin. We'll keep them different so that we can control this behavior independently on each element. So all this will be on 4 millimeter. Let's confirm this. Again, these parameters will come in additional set outside, so let's grab them, put them together into the set, and let's call this simply overrun. So now we can extend this curve. In order to do this, we will use extrapolation. But before we do any extrapolation, we have to predefine the points so that we don't ever select this point, because you can see here already that we are going over the edge, and in some cases this edge won't be here, so it can happen that you will lose the boundary representation element. So in order to prevent this, we will simply select our curve, if you find it somewhere. So we have it here. Distance on curve is of course as usual 0. Same for the other side, so we can copy paste it and simply reverse the direction of the curve. And now we have two very stable points that we can always find. Now we can do our transformation, extrapolation of the line. So we will select first point and extend it. Then on second support, extrapolated second side we cannot define even, or we can leave it to the element to take care of this. Do we trust the system? Let's try to trust it. Otherwise, in previous releases of Catia, there was no possibility to do both limits at once, and there was mandatory to do this extrapolation in 2 features. In this case we will do it in 1, we will try to do it in 1, so we have defined first point, first orientation, and let's hope that the other side is stable enough to do it for us. So beginning is exactly there where we selected the point, so edit formula, overall left begin. Now it's 4 millimeter, overrun on the end, left end. We'll have as well 4 millimeter. In this case we will do the curvature extrapolation so that we don't lose any, that we don't become any tangent break inside, so that we have natural transformation of this curve. So we extended it, and now we will project back this extended curve on the surface. And this is what we will use later for input. So in order to do this, we will use project, wireframe projection, select the curve, select the surface, along the normal. Do we need additional smoothing? Technically yes, because we can with this extrapolation again run into crossing with some edge, so let's do some smoothing. And if you remove this reference curve, you will see that the new one is now from beginning to the end. As well, those points we don't really need them anymore. Then now we have to do the same for the right side. So with slightly less description, let's do it quickly. Or we can simply here add right set. So now we'll do the right curve. So again, same procedure, selecting the curve, selecting the surface. Formula is of course in this case line width itself, and smoothing as we said before 0.01. Use same parameters when possible, and now we will extrapolate it. So As we realize that we can use only 1 point, we will just put 1 point on 0, and we'll do extrapolation. And in this case, formula right begin, formula right end, everything is in curvature, and now we'll project back this curve with smoothing of course. So let's add the smoothing, curvature, and let's hide these inputs. So with second point here as well we didn't use, so let's remove it. In case that you use an older release of Catia, you will need that second point, so please feel free to use it. Now it's slowly time to reposition our geometry, so to bring this pattern close to the references, to the input in geometry. So in order to do a repositioning, let's create one set called repositioning. In Simline we add a new set, repositioning. As we are using big capital S characters, let's do it the same. In this case I will use one trick that you might not be able to use if you are not using imaginary shape, but I will use it only to simplify the positioning, so that it's easier to understand why we are doing it, what we are actually doing. So I will just grab this element and translate it in the reorient it in the same position as it was on reference geometry. So we can see our line is here, this is the direction, so we'll put it in similar orientation, and additionally we will need this 180 degrees approximately, and we can as well do some translation here to put it above or below the same line itself, so that we can see in which orientation we have those axis systems and where the begin starts and so on. So if we update this, our geometry will come with, and now we can see that axis system which is defining beginning of this pattern is correlating to the beginning of the surface that we have here. This will help us to see where this axis, newly created axes will have to look to. So we can go back to generative shape design, and we can start adding axes. First we'll put axis system here in the middle, then we'll put axis system there in the middle. Why in the middle? Because then when we are doing wrapping of those surfaces, then chance to do mistake by calculation is lower. In order to do it on the upper one, we have our preparation set where we started creating those base elements. Where was the line? And first point is exactly here in the middle, so middle point, and then we will need axis system, which is same as this one. So reference is not absolute axis system, reference is in this case actually is absolute axis system, as we didn't rename it, but if it were not it would be now renamed here, and we need the same orientation as that. On the lower one, the story is slightly trickier. We will start as well with point in the middle, but then we will need additional two lines, and we cannot use anything from this axis system, as we want to keep it independent from this orientation of the surface, which can stay in any single position in the space. So we'll have the line which is tangent to this line, to this curve, starts on 0 and ends in, let's say, 20 millimeter. This dimension itself doesn't matter, it's only here to define our where the axis will be. Other direction that we know and always know where it is of course the normal. Flip so that it looks similar to axis. It won't make any difference because the orientation will logically stay the same. And now we can do axis system here, and we can compare it to upper one. So origin is x-axis is the lower one, and the axis that goes up is actually z. So we'll select the z, and in this case it's mandatory to rotate to this z to reverse it. So now we have two axis systems that are correlating together. Next part is of course to move geometry from this axis system here up on the lower one. Before we do this, let's simply pack this in additional set so that it doesn't disturb us later when we don't need it. So we'll add additional geometrical set. We will not even name it. And now we can grab all this geometry that we want to have, that we want to use down there. We will transfer it axis to axis. So we will need transform, translate, axis to axis. Element won't be one, it will be all this set. So we have to select that face, outer curves. You can even try to find them in the tree. Where are they? The translate, the seam pattern, the join, and the blackout. So all these elements will now we have selected. Then references, of course, this axis system target is another one. And now you will see, keep all, of course, as the elements are, these stitches are not connected. It will ask us always to keep sub-elements. Later while updating it won't, so it doesn't really disturb. And now we can see we are coming closer to the geometry where we want to be. These all references in the basic shape in this preparation actually we don't need anymore, so we can hide the whole set. Repositioning geometry we don't need as well, hide. So now we need only this. Next step is to transform, of course, this pattern on this surface. How we are going to do this? The plan is relatively simple. We want to use wrap surface. Wrap surface should be hidden somewhere, probably in different app. Generative shape optimizer, morphing. So we will need morphing tools, and even though we would use a wrap surface, we cannot do it directly because as you can see here, this element is longer, or doesn't simply correspond to the supporting surface, as supporting surface can have a lot of radius here, and the projection in direction simply doesn't work. So what we have to use here is a projection direction in normal, and unfortunately normal doesn't support multi-phase surfaces, so we cannot use this raw input. First we'll have to create additional element here which is having single phase. Regardless how long this element is, it always has to contain out of one single phase. Blend was first idea to do it, but as you can see it contains a lot of points, so technically you could do curve smooth on it and try to blend it, but unfortunately if the curvature of the reference surface is relatively strong, this blending won't work. That's the reason why we'll use shape morphing, and this is something that we'll put in additional geometrical set. So let's use this line and rename it into the repositioning, into the single phase. How we are doing this single phase, we will simply select shape morphing, element to deform. We actually prepared and brought with us, and it's exactly this upper surface that we created. Attenuation is something that will later control how much tension actually you have in this transition between surface, and from experience the very strong attenuation shown as the best one. And now we can do coupling of references and targets. So one curve, one support, and constraint will be tangent, and we will be tangent on this lower surface. On the other side we will do the same, so curve surface, add new one, that's fine. So we changed it from one to another, we want another one, so right one now, and support is again the same surface. So we did left side, right side, and if you do preview, you will see that we are getting this plane now actually transferred into this surface, and it will come on top of it. And with the strong attenuation you will lose actually a relatively small amount of this curvature. So if there was a very hard sharp edge, you will actually get something relatively smooth, and the seam itself will be able to apply it on top of it. So let's confirm this. Now we have everything that we need to transform with a wrap surface. For this wrap surface we will again need this surface there. Those curves on left and right we will not need anymore, so we can even hide them. They did their job, and now we'll just apply this geometry on the face. Now we finally came to the end of this creation. So finally we are going to apply this shape, this stitching on the geometry. So we will use a wrap surface, but before we do that we will add simply one more geometrical set, which we'll call in this case result. First one will be the line that we will transform, so wrap surface, element to deform is exactly that line, so this transformation 4 in this case. Reference surface is the surface that we used to make a morphing, and then target is morphing, and of course we use normal. If you press preview you will see the upper one is adapted into the lower one. We don't care about this gap between elements because it was known that we will have it, so we don't need this anymore. Now we will just need this supporting surface, and of course blackout. This line, this element here is seam line itself. Let's put it in corresponding set. Not duplicate anything, we just want to create additional set. So stitches, seams, however you want to call it. Next one is copy, paste, 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 so we don't have to define everything again. We'll simply replace the element to deform, and now we have the supporting surface moved down, as well this morphing we can hide so that it doesn't disturb. Next step will be to cut this out, this part of the surface, and this will do after we finish transformation of the blackout. But first we will call this face. Then same procedure for the blackout. So we have blackout here, wrap surface, and again transformation reference is now the surface below. In this case now we get as well our blackout surface. As well we need a left and right surface here, and we will do that as well. We'll add additional geometrical set. No, we'll call it cuts, and we will cut the left and right side. How we'll do it, of course, split with a remove element, and somewhere here we had the point that we used that is positioned in the middle on that curve, on that surface. So we can use split, transform, split our input surface with curve, and element to remove is of course that what was staying here on the point. So it was that, was it 14 clear, wasn't it? Not two of them. Was point 15 of course, not 14. 14 is the one that was an axis system outside. You have to freeze now? No. So we have left one. For the right one we have to do the same procedure, or we can copy paste and simply replace the curve, cutting curve. So cutting curve is actually then the right one, and this element we can remove, and this will give us now the clear result where these stitches are applied on the geometry. Before we continue, we can simply rename this couple of features here, so that we don't come in situation where we had the template where we had this user defined feature where those elements actually didn't have the names, and we can predefine them by renaming this. So we'll call this stitch line or seam line. This we'll call face. This of course blackout. Cut left and cut right. Before we continue, let's save this model. Before we pack everything into user defined feature, let's clean up a bit. So we don't need repositioning, let's hide it. We don't need basic curves, let's hide them. We don't need the input, or we will need parameters, so let's keep them open so that we can easier select them. And yes, we can see as well here that if we simply remove this edges with smooth edge, if you take a look, we will see that we have 12 elements, even though this line was 50 millimeters, so 10 elements were optimal number. This was because we had these extra elements, which we can in this case put on 0 and update our models just to prove that the model is actually stable. Additionally, we can go back to imagine a shape. This is the step that you don't have to do, but it will show us that the model is relatively stable. So we can select our geometry and rotate it in some different orientation, and what we expect here is that nothing actually happens. So if we update this, update is supposed to go through, which will prove us that this can be applied into any situation. As well, if we turn on back the shader with edges and add an additional span here into subdivision, cut, and let's move it a bit in normal so that we have really strange situation. So we have one surface, other surface, and now the transformation looks completely different. Even additionally, we can grab these two elements and extend them in some direction, doesn't matter, and we can hide those and make update. So as you can see, this will follow, and now instead of 10 elements we'll have 19 elements. Of course, as this is a template is it's relatively smart to keep templates as light as possible, so minimal amount of elements so that it's data that is saved on in the physical disk is actually the minimal, because this will later save you the loading times when instantiating these elements. So let's slightly optimize it back. Let's grab those two and let's shorten it again. So as you can see, we are updating, nothing is changing, so we can play with this like a rubber gum now. Update. So we are now extending from one side to another side. Vertex not found. That's a good question. Where? Vertex not found for the input, which is very funny because this is only thing that we didn't try to prevent from breaking down. But we can ignore this one as this is not real issue. We know where it's supposed to be, so beginning was actually update, vertex edit was actually here on intersection. Where is intersection? That's intersection. In this case we'll simply fix it, quick patch it, otherwise we're supposed to put again the point on 0 instead. And let's play a bit more with this. So now we'll have again the same issue with this vertex. But as this vertex is not part of the template, it's not really a reason to worry about. So we have simplified our template. Our template is relatively clean, smooth without smooth edges. Now we can as well add a couple of colors on it so that eventually when template is instantiated that these colors are as well taken with. So let's change the color of seam into the white and blackout definitely into black, and we can even change those faces into something else. As you can see, this can happen as well under some conditions, that internal tangency is unfortunately in some cases not respected, but unfortunately there is not much what you can do about. Additionally, if we try to join these two elements, join, we will not find it in image and shape. Let's go generative shape design. We have join here. This is something that we will not take with us, as in some cases this is better to keep separate and then join later when instantiated. But if we join this element, usually you will need slightly more merging distance. You will see that actually those surfaces are staying tangent, so you will have one clean result all the time, except in such cases unfortunately really you cannot do much about. So this join we will not need. In case that you want to play with other parameters, feel free. So if we change this 4.5 to 6 and update, we'll have slightly bigger elements, less of them, and our template will survive. But as we are using relative standard, standard was actually 30 control 7, 30 divided by 7 was desired result for interior in car industry, and this was given 4.2 millimeter per length of the object. We can use as well this number. Let's make a template out of it. Let's make a user-defined feature out of it so that we can use it in other parts. Before, we'll simply save it once again. Of course, in order to make a template out of it, we want to have everything again in this seam line, and you can see all these relations are still outside, so let's cut them, or will cut even work. Copy to clipboard, references paste, or drag and drop into the references would do it as well. Update, so we'll have again the same clean result, and actually we have only two sets. Bar body is empty as we didn't do nothing with it. We have our input and we have our output, and this output we want to use now as input for our user-defined feature. It's amazing how all these icons look the same. So user feature, in this case, is slightly different than with other one. Here we will have intersection and subdivision as inputs. We will call this seam line. Then we'll have our inputs. We can rename those inputs into curve or whatever you want to have it as a name, and this surface. Then meta inputs, we don't need nothing. From parameters, now we're supposed to choose all the parameters that we need later when we want to modify them on instantiated geometry. So in case that you need more, you can of course add more. I will just reselect those from the previous one plus a couple of new ones. The calculated length is not interesting to us, number of elements is not interesting to us, mapping length is not interesting. This extra elements is interesting. Overruns are very important if you want to control the edges, so let's add those as well. From parameters, that's supposed to be enough. Picture again of the template, why not? Let's hide the tree, F3. Let's grab screen. Of course, different icon you can always add if you prefer different icon. Black box protected, yes. For support testing purposes, you can use white box, where this user-defined feature will behave actually as a power copy. And now we have our outputs. In this case, you can see that outputs actually do represent exactly that what we wanted, but there is one mistake. We don't need join. Join is not part of that template that we want to have. We want this structure where this was not joined. So we will unfortunately say cancel, delete this join, and now make a template out of it. So let's select again the seam and let's make the feature seam line curve surface parameters screen, grab screen, outputs, and now we have to see if our outputs are responding to that what we want to have. So we want our sim line, which is there. We want to have face, we want to have blackout, we want to have those cuts left and right. So I would say this is exactly what we want to have. So let's confirm this. And in this way, we don't need references. So in this way, we created a sim line template. Why it's not updated? It's always a question. So local update will actually do this update. And let's save. And technically that's all, folks. In case that you want to see how to apply this, you can see that in the first video of the series. So in the intro video, we will use exactly this now to prepare the intro video. So I will use this this simming line, this template, to apply it on realistic objects in order to show you what you can actually create with this template. Thank you for watching, and if you like the presented result and if you learned something, feel free to put a comment in my video or at least a like. Thank you.